All right, so let's do lesson 2, exponential and logarithmic functions, and we're going to actually get into logarithmic functions. So, quick review of an inverse of a function. Okay, inverse of a function is when you interchange your x and your y coordinate. So, for instance, if x was x and y was y, x is now y, and y is now x. So, for instance, if you had 2 and 1, the inverse would be 1 and 2. If a function is defined by an equation, the inverse will be determined using the following steps. First, you change x and y, and then you solve for y. So if y is equal to 2x plus 3, you would change that x is equal to 2y plus 3, and then I would say x minus 3, because I would subtract 3 from this side, and then I would divide by 2, and then that's equal to y. So you always solve for y. Okay? The function is defined graphically by using the reflection line of y is equal to x. Okay? So that's on your graph. There's this y is equal to x right there. So if there's a point here, the point would go over that line. If there's a point here, it would go over the line and it would be on the other side. Okay? The domain of the inverse is the range of the original, which makes sense. Your x's are your y's are your x's. So the domain becomes the range, and the range becomes the domain. Okay? If any time you need to go back and look at this, pause it, go back, rewatch, do whatever you need to do. Okay? So quick class exercise number 1, draw the graph of the inverse of the function shown on the graph. So I'm going to take this one. I know the x is 2 and the y is 0. So I'm going to make the y 2 and the x 0 right there. This point right here, the x is 1 and the y is 2. I'm going to put it over here. X is 2 and the y is 1. If I look at this point here, the x is 3, the y is minus 2. I'm going to make it the y is 3 and the x is minus 2 over here. Okay. If I look at this, the x is 0, the y is 4. So I'm going to make the y 0 and the x 4. And then I would just draw the line through there. Okay. As best as I can. Like that. And what you're going to notice is here's your x-axis. These 2 points are equidistant between them. Oops, sorry. This one and this one. Holy moly. You're in grade 12. Okay, so I'm going to do my best to draw a line through these. Like that. And what I should notice is whatever I have on one side of the line, if I draw a straight line with that x equals y, I should get the other point. So these should all be parallel. This one, this one, this one, parallel. Okay. The function passes through the points 10 and minus 16 and minus 10 and 24. So if we're writing the inverse, I would have minus 16 and 10 and 24 and minus 10. Okay. The equation is y equals 4 minus 2x. So if we're going to solve this, I would say x is equal to 4 minus 2y, and then we solve for y. So backwards BEDMAS. Y, not y, x. I'm going to subtract 4 first, minus 4 on this. No, I'm going to do this all over again. Okay. So if I'm looking for this, I'm going to exchange my x and y. 4 minus 2y and then I have to solve for y. So I'm going to start with the opposite for BEDMAS. So I'm going to have x minus 4, and minus 4 and 4 cross each other out. So then I'm going to have the equals minus 2y, and then I'm going to divide by minus 2, minus 2. And this is going to be equal to y, because that crosses itself out. So then I have a negative 1 over 2x, and a negative negative, so positive 2. And that is the inverse, the equation. Again, if you need to stop and pause and go over that again, pause, go over it again. Okay? Explore the inverse of y equals 2 to the power of x algebraically. Excuse me. So attempt to do this and then solve for y. So then I would say x is equal to 2 to the power of y. And then solve for y. We have a wee bit of a problem with what we know so far. We do not know how to solve for y, if we're going to be honest. I mean, you could y root it, but then that's just going to be not working very well for us. Okay, so we need to come up with a different way of doing this. All right. So we're going to try this graphically. So let's fill this in. If x is equal to minus 3, then it's y is equal to 2 to the power of negative 3. 2 to the power of negative 3. So that's going to be 1/8. Right? This becomes 1 over 2 to the power of 3. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay? Which means this is going to be 1/4. This is going to be 1/2. This is going to be 1. Right? Any number to the power of 0 is 1. It's going to be 2. 2 to the power of 2 is 4. To the power of 3 is 8. Power of 4 is 16. So now I'm going to put, this is the coordinates, right? Negative 3. So 1, 2, 3. And 1/8. So that's going to be right here somewhere. Negative 2 1/4. Negative 1.5. 0 and 1. 1 and 2. 2 and 4. 3 and 8. Okay, let's do our best. Make a nice line there. Well, somewhat okay. And then we have x is equal to 2 to the power of y. So in this case, we've put the y's in here. And this becomes 1/8, 1/4, 1/2, 1, 2, 4, 8, 16. So now when y is equal to minus 3, x is equal to 1/8. And when y is equal to minus 2, x is equal to 1/4, 1, maybe there, 1/2, 1, y is equal to 1, x is equal to 2, y is equal to 2, x is equal to 4, 3, and 8. So let's give this a try. There we go. So again, this line here, x and y are equal. X is equal to y. These are directly opposite each other. on that. Okay? Oh, yeah. So the line of symmetry is x is equal to y. Okay? Or y is equal to x. Y is equal to 2x is the exponent function. Exponential function base 2. The inverse, it's also a function. We're unable to write its equation in terms of y. To do this, we introduce a new function, logarithmic functions. Okay? So how you write it is like this. Y is equal to logarithm of 2 to the power of x. This is your base, and this is your exponent. In general, we write y is equal to log b of x rather than x is equal to b to the power of x to the power of y. To express the inverse, it is the inverse of y is equal to b to the power of x. Okay? X cannot be 0. X has to be a real number. B has to be greater than 1, and b cannot be equal to 1. For all the same reasons that an exponential function can't. Okay? Y is called the value of a logarithm. B is called the base, just like it is in this case. And x is actually called the argument. So that's something new. Argument cannot be negative. Same reason as before. Okay? Okay, so y is equal to 2x and x is equal to 2 to the power of y are on this graph here to the right. Write the label y is equal to log 2x beside the appropriate graph. Complete the table below. So y is equal to 2 to the power of x. Let's do this one first. X can be any number at all. So x is all real numbers. The range, y can only be greater than 0. So y such that y is greater than 0 and it is only real numbers. X, there is no x-intercept. The y-intercept is 1 and the asymptote is y is equal to 0. Okay? Now, for the other one. X can be any number along this line. X can be on that graph. If I go down here, can I? What if it's negative? This looks like it's getting closer and closer and closer to the y, but it's not going into the negative. So x cannot be a negative number. So in this case, x such that x is greater than 0, but it also must be a real number. Okay? Now let's look at this. Can the y, any y that I have, can it be on this graph? It will eventually hit this graph. If I do a negative number, it will be on this graph. So now y can be all real numbers. Okay? The x-intercept is 1. The y-intercept, this gets closer and closer and closer to y, but never actually hits it. So there is no y-intercept. And the asymptote, what it never actually touches is now x is equal to 0. So if you notice these trade places, these trade places, these trade places, these trade places, and this becomes x or y. Okay? Okay, so if we are looking at this, the point 8, 3 on this graph corresponds to 3, 8 on the graph of y equals 2x, right? Your x and your y swap. The point 3, 8 on this graph means that 8 is equal to 2 to the power of 3. The point 8, 3 on this graph means that y is equal to, or I should say 3 is equal to the log 2 of 8. Okay? All right. When you're using your graphing calculator to show logarithmic functions, you actually put it in like this. And we'll look over what that means in a different course, in a higher level course. Okay? So you'll notice here, that's what this is. Okay? So y2 is equal to log x over log 2. That's how you put that in. You're going to make your window this, -3 up to 7, and each of the little lines is going to be a half 0.5, and then your y is going to be the same, 3 to 7, and each of the little lines is a half. Okay? You're also going to graph y is equal to 2 to the power of x so that you can see it on the graph at the end. This is what your graph should look like at the end. Okay? So pause me right now and go and look at that. So when I look at that, I put them over on this side. You can kind of see it over here on this side. So y is equal to log 2 of x. I put that in, you can see this green line. Now when I put in log x over log 2, I'm just going to click that on. And you're going to see it goes straight over the green line. Okay, if I put that on or off. So it's just to demonstrate that those are equal. And then I put in y is equal to 2 to the power of x. And then I've also put in x is equal to y. And you're going to notice that this point is exactly the opposite of that point. Okay? Right across here. This point and this point. Right across here. This point and this point. Right across here. Okay? All right. So next I want you to look at b with me. So log b, we're going to investigate what that b does. Okay? So the first thing I want you to do is to put in log 3 of x, log 5 of x, log 1/3 of x, log 1/5 of x into your calculator. When you have that done, set your window to -1 to 11 and -4 to 4. And then turn me back on again. Okay, so you should have a graph that looks like this. The first one is log base 3 of x. Then we have a log base 5 of x. Notice that they both go through this point right here is 1 and 0. Okay? Why is that? Because x to the power of 0 is 1. And then we switch x and y, okay? And we're just going to get rid of log base 5 of x, and I'm going to put in 1/5, okay? So 1/5, you're going to notice that it's flipping it over, sorry, not 1/5, 1/3. It's flipping it over the x-axis, just like before it was flipping it over the y-axis, okay? So your points here is going to be flipped over the x-axis, okay? And if I change that up, so we do 5 and 1/5, it does the same, okay? Flips it over the x-axis. Now if I did log base 5 and log base 3, you're going to notice along this blue line, which is log base 5, it's much steeper or more steep than log base 3. Okay? It's getting closer to the x-axis. Okay? And then the black line here is 1/5. And again, that's getting closer than the purple line, which is 1/3. Okay? You should notice that there's an asymptote here where y is equal to x is equal to 0, the y-axis. Okay? And you'll notice they all go through this point, 1 and 0. All right, so if we go back to the book really quick. Draw it in as best as you can. And then we're going to complete this table. We're going to add in our values here. Okay? So, y is equal to log base 3 of x. That is this red one. So if I look at this red one, my domain, what my x is equal to, x is equal to everything above 0, right? But it can't be negative. So x such that x is greater than 0 and is a real number. Your range, what y can be equal to. So if y is 4, that'll eventually be on that line. If y is -2, it's on that line. This goes, it can be anything on that line. Y can be anything, as long as it's real. So now if we're looking at the graph again, your x-intercept is 1. Okay? And your y-intercept doesn't exist. It never goes over the y-axis. Now your your asymptote is going to be x is equal to 0 rather than y is equal to 0. And your x value when y is equal to 3, when y is equal to 3, let's see here. Oh, my goodness. When x is equal to 3, y is equal to 1. I did that backwards, didn't I? Okay, now let's look at the next one. Log base 5 of x. So your x-intercept is still there. There is no y-intercept. Your asymptote is your asymptote is x is equal to 0. And when y is equal to 1, x is equal to 5. Okay, so let's put that in there really quick. X such that x is greater than 0. X is all real numbers. Y can be everything real. X-intercept still 1. Still have no y-intercept. Your asymptote is still 0. And y is equal to 5. Okay, let's move on to 1/3. So I'm going to put that one in. So here we go. Still have an asymptote of x equal to 0. It's still going through the x-axis at 1. When y is equal to 1, y is equal to... Should be 2/3, I think. Wondered any. Oy, oy, oy. Anyways, what you're going to notice is this is going to be 1/3 right here when y is equal to 1. 0.3333 continuous. Okay. Okay, so x must such that x must be more than 0, can't be negative. X is all real numbers. Y is all real numbers. X-intercept still 1. There is no y-intercept. Asymptote is still at 0. And this is 1/3. Okay. Let's look at 1/5. Okay. So your x-axis gets crossed at 1. When y is equal to 1, x is equal to 0.2. So that's 1/5. There's still this x asymptote here, x equal to 0. Y can be any number. Any number at all will be on that line. And x cannot be below 0. So let's put that in. X such as x is greater than 0. And any real number. Y is is any real number. Your x-intercept is 1. There is no y-intercept. Your asymptote is x equals 0. And when y is equal to 1, x is equal to 1/5. So let's call this what it is. X, such as x is equal to 0. X has to be a real number. Y is all real numbers. X-intercept is 1. None. X equals to 0. And B is what x is when y is equal to 1. Okay? State the basis of the functions in A, whose graphs are increasing from quadrant 4 to quadrant 1. Quadrant 4 to quadrant 1. Increasing. So if I look at this, quadrant 4, did I say quadrant 4 to quadrant 1? It did. I would say this is going from quadrant 1. Quadrant 1 decreasing into quadrant 4. I would say the same for this one, right? starting in quadrant 1 and it's decreasing into quadrant 4. So let's try these ones. Starting in quadrant 4 and increasing into quadrant 1. So that's when the log base is 5 or the log base is 3. So if it's greater than 1, that always seems to be our point, right? So when b is greater than 1, or when 0 is less than b is less than 1, it's going to decrease, okay, from 1 to 4. Okay. Okay, so there's two special kind of logarithms that we're going to talk about. The first one is with a base of 10, and the second one is with a base of e. Okay, so when you have y is equal to log base 10 of x, you simply write it as y is equal to log x because it is the common logarithm. So if you would please graph y is equal to log x over log 10, and then y is equal to log x. So pause me right now and do that. You should have one line right over the other. Okay, so that's all that is. Okay. Now, ln is a natural logarithm. It has a base of e, which is that special number that we learned about. Okay, 2.718, blah, blah, blah. So log e, or ln, log base e of x, is written like this. Logarithmic natural of x. So when you put it into your calculator, you do log x over log e. And then I also want you to look at y is equal to ln x. Put them both in your calculator and figure it out. See what you find. Pause me, please. Okay. So the last bit of this is to figure out what a does. Okay. So we will investigate how changing the value of a affects the graph of y equals a log b of x. Okay, so when a is equal to 1, we're going to put in log base 3 of x. Do this one first, and then do all of these and see what you find. Okay, so at this point you should have these in your calculator. And I want you to look at all of these graphs. Tell me, I'm looking at b right now. Does changing the value of a in the graph of y equals a times log base b of x alter the domain? So if I look at this, x can be everything greater than 0. It changes nothing on all four of these graphs for the domain. For the range, what y is equal to, y is still equal to everything. Doesn't change anything. The x-intercept doesn't change a thing. For all of these graphs, they go through x equal to 1. The y-intercept, there is no y-intercept for any of these, so it changes nothing. The asymptote also changes nothing. So what does it change? What does it change? So if I look at these, 2 and negative 2, it flips it over this axis, right? If I look at 2, negative 2 is the purple line, and negative a half is the black line. So it makes it curve in towards this x-axis much quicker, right? It makes it much more steep. The same should be if we do 2 and a is equal to 1. So the blue line here is closer to the x-axis. When I times it by 2, remember I'm taking the y and I'm multiplying it by 2. So it's going to be double that, okay? So it actually pushes it away when you increase the a. So no, it does not change the domain. No, it does not change the range. X-intercept, y-intercept, or the asymptote. There are any differences in the answers to B if the base of the logarithm is between 0 and 1. So if you were to put in here instead of 3, 1/3, for each of these, put in 1/3 and see what happens to your graph. Do any of these change? So pause me and go and do that. So the answer to that is no, it does not. However, the shapes of the graphs do change. Okay? So if A is greater than 0 and B is greater than 0, the graph increases from quad 4 to quad 1.
Oh, thank you.
If A is less than 0, so like a negative number, then the graph decreases from quad 1 to quad 4. If B is between 0 and 1, like it's a decimal or a fraction, and A is greater than 0, the graph decreases from quad 1 to quad 4. And if B is between 0 and 1 and A is less than 0, the graph increases from quad 4 to quad 1. Okay?
We get the basics. We get all these basics.
Okay, so if we're looking at this, the following summarizes the basic characteristics of the graph of the logarithmic function y is equal to log b of x, where b is greater than 0 and cannot be equal to 1. X-intercept, 1. There is no y-intercept. The domain is x such that x is greater than 0, and of course is a real number. The range is y, can be all real numbers. The y-intercept is now the asymptote, which you can write as x equal to 0. If a is greater than 0 and greater than 1, then the whole thing is going up. If a is greater than 0 and b is between 0 and 1, then it's decreasing. If a is less than 0 and b is greater than 1, then it is also decreasing. And if a is less than 0 and b is between 0 and 1, then it is increasing. Okay? This is the equivalent of this. B is the base of both. So the inverse of y is equal to log 3 of x would be y is equal to 3 to the power of x. And the inverse of y is equal to a to the power of x would be y is equal to log base 8 of x. Which of the graph could not represent the function y is equal to a log b of x? Well, let's look at this one. Goes through the x-axis, gets closer to the y but doesn't cross. This is getting closer to the y but it's not crossing. This one seems to be getting closer to the x but not crossing. And so we should see this as a problem. Okay? We're going to assume that it's not crossing the x-axis. Okay, that's it. Stop and do whatever you need to do. Go back over the lesson.